All right, so far we've learned the power rule and the product rule, and today we're going to learn the quotient rule. So you can tell from the name, quotient rule is for taking the derivative of a quotient, and usually when we say a quotient, what we're talking about is a fraction. So we're going to be talking about two different functions, one over the other, f of x over g of x. And remember, in order to want to use the quotient rule, each one of those should be a function of x. If either one is constant, then you don't really need the quotient rule. You can get around the question using just the power rule, which ends up being easier. But if you do have a fraction and you have a different function of x on top and bottom, that's when you want to use quotient rule. So here's the quotient rule. Well, this isn't the quotient rule, this is the setup. But this is what the quotient rule is for. It's for taking the derivative of a quotient, f over g. And here's how we're going to do it. What we do, and this is kind of the order I usually do it, the very first thing I do is I take the derivative, or the bottom, the denominator of the original function, and just square it. Because that happens in the quotient rule. You always end up with your original denominator squared. Now, for the top, what you guys notice is it looks exactly like the product rule, except it has a minus in the middle instead of a plus, and that's a good way to remember it. So if you remember product rule from the last day of notes, it was f prime times g plus g prime times f. And that's usually how I think of it in those two steps. So basically, when I'm remembering the quotient rule, what I do is I say, well, I already know the product rule. Let's just think about what's different. So the differences are, number one, there's a minus in the middle instead of a plus. Other than that, the top is exactly the same. The other major difference is it has a denominator, and that denominator is g squared, or the original denominator squared. So remember I told you guys for product rule, I like to think of it as a first function and a second function, and I do derivative of the first times second plus derivative of the second times first. Well, I do the same thing with quotient rule, but instead of a first function and a second function, you have a top function and a bottom. So this is what I say to myself as I'm doing quotient rule questions. I go, okay, first of all, square the denominator. Like whatever the denominator is, just square it. Then on top, it's derivative of the top times bottom minus derivative of the bottom times top. And I underline minus because you have to remember that's the one difference between this and product rule. You have a minus instead of a plus. So let's go ahead and try one out. Let's find f prime of x for this function right here. And this is clearly a quotient rule question. F of x is a fraction. You have 2x plus 3, which is a function with an x in it on top, and you have x minus 1, another function with an x in it on bottom. So this is definitely a quotient rule question. So when I go to find the derivative, I'm going to set it up like this. I'm going to make this big long fraction, leave myself some room to work. I'm going to take the original denominator, x minus 1, and just square it. And just leave that. Like, just put it in parentheses, right squared, and leave it. Don't multiply it out or anything. And then on top, I'm going to have these four, I'm going to do kind of a fill in the blank again, like I did with the product rule. It's going to be the derivative of the top times the bottom minus the derivative of the bottom times the top. And I'll write it out for us here. This is the derivative of the top times the bottom minus the derivative of the bottom times the top. And I'm just doing that for the notes. Of course, you wouldn't actually do this if you're doing the question. You wouldn't write what I wrote in green there. Now, two of the things you automatically fill in, like the bottom function is x minus 1, so I'll just fill that one in. And the top function is 2x plus 3. So just like product rule in our last day of notes, all we got to do is take each derivative separately, fill in those last two bubbles, and then clean it all up. Now, the derivative of the top is actually just 2. So remember our shortcut rules for x to the first power are constant. The derivative of 2x is just 2. And the derivative of any constant like 3 is 0. So the derivative of 2x plus 3 is just the number 2. And then something very similar happens on bottom. The derivative is actually 1 on the bottom. Because the derivative of x is 1. and the derivative of negative 1 is 0. So all I have to do now is clean this up and I'll have my answer. So I'm going to leave the denominator for now. I'm going to distribute this 2 here, so I'll have 2x minus 2. And then I'm going to think of this here as a negative 1. Remember, I was subtracting. So I'm going to think of this as a negative 1 and distribute it. And you'll have negative 2x minus 3. So what happens is the 2x and the negative 2x cancel. And our final answer is negative 5 over x minus 1 squared. And that's f prime of x right there. So that's how quotient rule works. You got to be careful. You got to set it up. And then it's always derivative of the top times the bottom minus derivative of the bottom times the top. And the whole thing is over the bottom function squared, the original denominator squared. And then you just clean it up. All right, here's another example I want to do with you guys. F of x, this time I threw in a square root of x, make it a little trickier. We have f of x equals 3x squared plus 2 times the square root of x, and it's all over x. So I see a quotient again, and I think, all right, let's go ahead and do the quotient rule. But before I do that, I'm going to take that, and I pretty much always do this for derivative questions. Anytime I take a square root, I'm going to recopy it as a fraction exponent. So I'm going to rewrite this very quickly as f of x equals 3x squared plus 2x to the 1/2 all over x. And now I'm going to do the derivative work. So now I'm going to do f prime of x equals, I'm going to set up for a quotient rule again, which remember is that big long fraction. The first thing I do is I take the original denominator x and just square it. So my denominator is x squared. And then it's going to be derivative of the top times the bottom minus derivative of the bottom times the top. So we have derivative of the top times, I'll fill in the easy ones first. The bottom function is x. The top function is 3x squared plus 2x to the 1/2. And then it's derivative of the top, that's going to be power rule twice. So right now I'm taking the derivative of the top function. Let's start with the 3x squared. I do power rule. 2 times 3 is 6. Lower the exponent, you get 6x to the first power, or just 6x. Plus, and then I do power rule again. 1/2 times 2 is 1, so I'm basically not going to have a coefficient. I'll just put it as an x. Then you lower the exponent by 1. Now 1/2 minus 1 ends up being negative 1/2. So my derivative there is 6x plus x to the negative 1/2. And then the only other one I need is the derivative of the bottom. That's a very easy one. The derivative of x is 1. So the derivative of the bottom is 1. So again, it's derivative of the top times bottom minus derivative of the bottom times the top. Now let's distribute again. If I distribute this x here and here, I get 6x squared plus x to the, now this is going to be back to the positive 1/2 again. Because remember, when you're multiplying x's, you're adding the exponents. So that's an x to the first power. If I do x to the negative 1/2 times x to the first, negative 1/2 plus 1 is positive 1/2. So this is going to be back to x to the positive 1/2. And then I'm going to do the same thing I did in the last example. I'm going to think of this as a negative 1. Basically change those two signs. So it'll be minus 3x squared and minus 2x to the 1/2. And the whole thing is over x squared. Now if we combine our like terms, I'm going to move up to the top here. I'm kind of running out of space. Switch colors here. If we combine our like terms, we have 6 minus 3, we have 3x squared. And then we have 1 minus 2 would be minus x to the 1/2. And the whole thing is over x squared. And this can be simplified a little bit more, but I'm going to stop here. I'm going to say that's a correct answer. Like you could split it up and simplify each term a little bit if you wanted to, but that's fine. We'll stop here. That's good for an answer for now. Because I want to make a very important point about this question. There's actually an easier way to do it. So if you remember when we first started talking about derivatives, I said this is a good time for you guys to always be thinking about different ways to do questions. And when we did product rule, I showed you one. I said you can do it by doing the product rule, or you can do it by multiplying it out and skipping the product rule and just doing power rule. And that time, I wouldn't really say one way was easier. This time there is an easier way to do it. So when you're doing quotient rule, here's a good little thing to remember. If you only have one term in the denominator, you can kind of avoid the quotient rule. In fact, we saw a question like this in the power rule section. So let's go back and redo that problem. So here's our same problem. I did type it up as x to the 1/2 power instead of square root of x this time, just so I didn't have to do the extra step and change it. But let's do this. Let's say, I'm going to leave this f, this is not finding the derivative yet. I'm going to leave this as f of x. But what I'm going to do, and I showed you this trick earlier, I'm going to leave the top. 3x squared plus 2x to the 1/2 power. And instead of dividing by x, I'm going to think of it as multiplying by x to the -1, because that's what negative exponents are. It turns something into a reciprocal. Now if you distribute that x to the -1, and remember this is not the derivative yet, I'm still just cleaning up. When you multiply, you're adding the exponents. So I get 3x to the first power. That would be, 2 plus -1 is 1. Plus, and then I get 2x to the, that'll be -1/2 power. And again, just by adding exponents. -1 plus 1/2 is -1/2. Now I'm going to take the derivative. So I'll switch colors here to red. So when I switch to red, this is where we're actually taking the derivative. See, now it's no longer a quotient rule. You don't need to worry about derivative of the top times bottom minus this over this squared, any of that. It's just power rule. So we say, well, the first one isn't even really power rule. The derivative of 3x is 3. That's a kind of a simplified version of the power rule. If you have x to the first power, the derivative is just the constant. Then we'll do power rule. So now I'm going to multiply by the exponent. -1/2 times 2 would be -1. So I'll just put it as -x. Then you subtract 1 from the exponent. -1/2 minus 1, if I show that work off to the side. -1/2 minus 1 with a common denominator is -1/2 minus 2 over 2, which gives you -3 over 2. And that's your answer there. And you can see how much less work it was. Remember when I did the quotient rule, I filled the slide all the way down, and then I had to work up to the top to find some extra room and squeeze this in over here. I took the whole page. This is 3 simple steps. It's changing to a negative exponent, distributive property, and then power rule. So yeah, I think this was definitely the easier way to do it. The key is you can only do that when you have one single term in the denominator. You can't do that otherwise. So like, for example, our first problem from today, our first example, the denominator, I think it was x minus 1. You couldn't do that. You had to do quotient rule for that one. But that's the end of the notes for quotient rule. So we'll do our next assignment and I'll answer questions tomorrow.